Welcome to the chi-squared test of independence using Excel tutorial. So we're going to learn how to do a chi-squared test using the wonderful Microsoft Office Excel. For our data, we're going to be using a campus-to-campus survey. As you can see, there's lots of data, lots of observations, lots of different variables. So the first thing we're going to do is we're going to just grab the data we want so we can start working with that. So the first variable we're going to want to copy here is please indicate your status at Cornell. So we're going to insert that in a new sheet. Insert copy cells. Great. The next one's going to be have you ridden the campus-to-campus bus any time in the past 2 years? So we're going to copy that as well. And we're going to insert those copied cells. And then let's rename the sheet new data. Let's make this a little easier to know what's going on. So we can wrap the text. We can make these a little bigger. And we can make these headings bold. There we go. So now at least we can see what's going on with our data. So the next thing we're going to have to do is we're going to have to clean up our data a little bit. As you can see, we've got stuff that we don't need here, like these response titles. Let's get rid of those. And then we've also got observations that are incomplete. Either the person didn't indicate their status at Cornell, or they didn't give an answer to the question, have you ridden the campus-to-campus bus any time in the past 2 years? So that kind of makes our life difficult, and we've got to deal with that quickly. So the way we're going to do that is we're first going to select all the data. Just Control-Shift, scroll down, make sure you got it all. And we're going to use Excel's wonderful filter feature. So you just click data, you click filter, and then we're going to deselect the blanks for each variable. And what that's going to do is that's going to filter out every observation in which one of the variables had a blank. And there we go, wonderful clean data. So let's copy this data to one of the nearby columns. Delete the columns we don't need. Increase the size of this a little bit. And voila, we've got some beautiful looking data that we can actually do something with now. So now that we've got our data all cleaned up and ready to go, we're going to create our contingency table using Excel's pivot table feature. So select anywhere in the data, go insert pivot table, make sure the range is correct, make sure it says new worksheet, OK, and it's going to create for us this pivot table in this new sheet. Let's rename the sheet pivot worksheet. Alright, so we need to select our row and column labels. Let's drag status into row labels. Let's drag campus to campus into column labels, and we can choose either one of these and we can drag it down into the values, just making sure that it says count of. It's pretty important because that's the way it creates this contingency table. So now we have our pivot table, our contingency table, but looking at it we can see that there's certain cells, there's certain intersects where there aren't any observations. We don't have any alumni that haven't traveled in the last 2 years, and those that have would be too small to meet our expected value criteria. Same for family members over here, the same down here for undergrad. Then we've got this postgrad 6 over here, which is sort of on the edge, even though the 3 probably wouldn't cut it. So we want to check this one. We want to check to see if it would meet the expected value criteria of being greater than or equal to 5. So we're going to take its row, its column total of 138, times by its row total of 9, and divided by 256, which is the grand total. We see that, oh, it just wouldn't have missed our cutoff. So what we're going to have to do is we're going to have to group these together in order to meet that expected value cutoff. So we're going to group together alumnus, family member or significant other affiliated with Cornell, other, postgrad, and undergrad. And we're just going to copy these and go back to our new data sheet here and paste them. Any time in which the observation was one of these, we're going to group those all together. And in order to do that, we're going to use an if statement together with an or statement. So we're going to say if or, if this A2 over here was equal to E2, and we're going to make that a fixed reference, or A2 was equal to E4, so E2 was equal to E4, let's make that a fixed reference. We're just going to go down, so we're going to say if it was any of these, then we're going to meet the logical criteria of it being being true. Okay, so we're going to say if it's any of these, give us a response of true. If we get true, we're going to make it just other. We're going to make that label other. And if it's not, just return us what it was. So that if statement there is going to allow us to regroup all these columns, all these row labels. So we get that, we just copy down the formula. See, it goes all the way down. So we're going to just copy down this row. Going to go over here to where it was previously. We're going to say right click, say paste special, just going to paste the values so we don't mess up our formula, and then we can delete the rows that we don't need. So now we've got this regroup data, and to see how the regrouping worked, we can go back to our pivot table, we can say options, we can say refresh all, and almost magically it regroups that into row labels that would give us enough counts within the intersects. Performing the chi-squared test. So to do that, we're going to copy this pivot table over here. We're going to paste the values. We're going to paste it one more time. So this table over here, this is going to be our actual. These are going to be our actual values. This table over here, this is what we're going to use to create our expected values. So all the actual values we're going to get rid of in order to just show us what we're looking at. I'm going to put a border around that. So we're going to calculate for each of these values what the expected value would be. In order to do that, we're going to say the formula is column total times the row total divided by the total sample size. Okay, and there we go, and that would be our expected value. Let's edit the formula a little bit, just putting in some fixed references so we can copy it easier. For these row totals, we want the row to stay fixed, so we're going to fix the 29, put a dollar sign in front of it. And the opposite here, we want the column to stay fixed, put a dollar sign in front of it. And the grand total, we want everything to stay fixed. So there we go. And then let's copy it down. And we've got all our expected values. Great, so now we can actually get on to calculating our chi-squared value. We could do this two ways. We could create another table and calculate the differences squared over the expected value and aggregate all of those and use our table to calculate our probability, but instead what we're going to do is we're just going to use one of Excel's wonderful built-in features to calculate the p-value straight from these actual and expected values. So let's create a new title that says chi-squared p-value, and then we're going to use the formula chi-squared test. Double click on that. See, it tells you to select the actual range, so we're going to select the actual range, don't select the row values. The expected range, there's the expected range, and voila, that's it. There's our p-value for this chi-squared test of independence. You can see there it all depends on where we set our cutoff p-value.